So you're going to be doing piecewise functions, and the best way to describe it, looking at Desmos.com, so if you look at this, and I go down all these, there are a bunch of equations to make up this picture. Like if I just toggle this on and off, you can see, oh, this one equation, y equals 3, is this line right here. And you can see that there's a this right after it. This is like the domain, meaning I don't want to draw a line all the way across the whole graph. I just wanted to go a straight line from here to here, and that's it. And you can see a lot of these fancy graph, like right here is just that one little corner to turn. Okay. So all these have their own equation, and they're followed by this domain, so that only graphs it from a certain point that starts at to a certain point where you want it to stop. And that's more or less what you're going to be doing. If you look at the handout in front of you, there's only 2 or maybe 3 at most different functions. This one has like probably 100. But you can see what we're doing now leads into something much more. Okay, this thing goes all the way up to 152 different functions to graph this picture right here. And there's a bunch of them on here if you just want to go look at them. On again, it's decimals.com. Right. And you can see that each function has its purpose. And this is one of those things that really illustrates like the use of mathematics. You know, like there's some people that would actually look at like something like an animated movie and say, yeah, you don't really need to use math. And then when I show you this, you can see, well, just the picture of it is nothing but equations. And making it move is more equations. Like the whole thing when you're watching anything animated is nothing because it's all computerized now. Computer programmers, computer animators do. They write all these equations. So don't be one of those people that goes around saying no one really uses math, and you're going as you're watching a movie that's all animation. It's nothing but mathematics. Yeah, they do some hand-drawn stuff, but then they throw it through the computer to move it and make it talk and do all that stuff. They're not animating every little thing, just a general shape. And then it turns into something like this eventually. So something just still you can see is you would have to write what's that, 162 different equations just to get that on paper, just to get that on the screen, and then a bunch of more stuff to make it move. So we're not going to start with this. This is an awful lot. We're going to start with the basics, but just know it does lead somewhere that is realistic and has meaning. All right. So what this is called, when you take a bunch of equations to make one picture or to make one graph, it's called piecewise. So just so you know, if you're asked to make a piecewise function, we're talking about a bunch of small little graphs. And so first definition is piecewise just means many pieces. In this case, many pieces means graphs. And we talked about domain before. Okay, domain is that part of the graphing that says, well, I want to graph it, but I only want to graph it like for y bigger than 7. Right? It doesn't work if I don't have certain restrictions. I don't want to draw a straight line across the whole graph. I just want that straight line in this small little piece. That's why on the pictures you have, or on the graphs you have, they start and stop at different places. So the domain is where do they start and stop. So 2 parts. What's the function? What's the domain? Okay. All right, so let's get to it. So just watch up here. Go through it. I've color-coded everything, so it's hopefully that helps. But just looking at both of these, first thing we're going to do is just get the equation. Identify that there's two different functions here, so you want to get the equations of both of them. Do you guys remember what is the slope of a horizontal line? 0, I heard. So yeah, these are both y equals 0x. And what's the y-intercept for each of them? Okay, so what's the y-intercept here? Yeah, 20. So this is y equals 0x plus 20, which is the same, of course, as just y equals 20. And this is y equals 0x plus 80, which is the same as y equals 80. So the first step is just, what's the equation of line? That's something we did in October. Like I said, if you looked at that and you knew, okay, the slope is 0, and you found the y-intercept real fast, that's where you should be. It should feel that easy. If I asked you that question, you couldn't get it right in a million years. Well, this is a lot of review built into this, which is good because the final's coming up, which includes all of it. So the first part is the equations. The green one is, again, y equals 20. And the blue one is y equals 80. Okay? So you put the functions here. The equations go here. Functions or equations. And they're usually, not always, but usually in the y equals mx plus b format. And over here is going to be the domain. That tells us, well, from where to where. This line doesn't go all the way across the whole graph. It starts at 0 and it goes to 3. And this one starts at 3. You can see here. This one starts at 3 and it goes on forever. So we just have to write that down. Recall, if you want to do something that's like we do here, like, oh, it's from 0 to 3, the mathematical way to do that is to say, well, x is between 0 and 3. So you do this. We write that in-between statement. Okay. So x is in the middle of 0 and 3. There's a solid dot here, which means equal. So we want to actually make this one an equal to 3. So less than or equal to 3. The purple one starts at 3 and it just goes on forever. It starts at 3, so x is always greater than 3. Notice how there's no equal to, it's an open circle, so I don't draw a line. Okay? And that's going to be it. First get the equations. Sometimes you have to count the rise or the run and do all that. And then you have to do the domain. Remember, domain is always x. So I'm always looking down here from 0 to 3 and from 3 or more, 3 plus. Always looking at the x for domain though. And yeah, we did this in October. We did actually this in November. We're just combining everything together. I'm going to have you guys try the first one in the upper right-hand corner. It's very similar. Okay. Go ahead and give that a shot. This time there's 3 of them. You know, the ones I showed you on the online, they had 100-something, 160 equations. So you can have as many as it takes to make that picture that you're trying to make. Remember, always look at the x-axis for domain. So what's the mathematical way of writing from 0 to 2? And then the purple is from 2 to 4. And then the salmon color is 4 and above. So how do you write these using an inequality? That means the exact same thing. So anytime you have a beginning and end, always use in between. And then here, since it just has a starting point at 4 and goes greater, Just like that. Now keep in mind though, there are a couple closed dots right here. So there's a closed dot on the first equation at 2. So I want to make sure the first equation at 2 I have an equal to. And there's a closed dot on the purple at 4. So on the purple one at 4, I want to have an equal to. Anywhere there's a closed dot, make sure you have the equal to on the inequality as well. And this one was what? Y equals 5, y equals 15, y equals 25, right? So make sure you associate these from one number to another with this format, in-betweens format. And then if it's a number and above, that's greater than. If it was a number and below, like on the next one, it'll be a less than. But yeah, we did this for weeks and weeks and weeks. What's the equation of a line? We did these for a good week, finding the and ors, those inequalities with and ors and in-between statements. Just combining it all together into one problem. Okay. And of course, this idea leads to something much bigger, like making a picture of something like on decimals. All right, so go ahead and try the next one below it. Very similar. Only 2. And again, from left to right on the graph is top to bottom in the listing of the functions. All right, so we have the equations are not so bad. They're still the slope of 0, right? So we still have y equals -3.
Oh, there we go.
Y equals 2. And I mentioned before, is subtle, but it's very important. You have to remember that the domain is only x. So when you're trying to find a number here, you have to look only here, only at the x-axis. Some of you are saying, oh, it's at 2. Like 2 is right here on the x-axis. It doesn't start at 2. See? Where does it start? Yeah, it starts at 0. That's right in the middle. So the green starts at 0 and it goes this direction. That's an arrow. So it's going to be less than or equal to close dot 0. And then this one starts at 0 and goes up. So since you're using the variable x, that implies you're using the x-axis to where it stops and goes. Notice how none of these have a beginning and end, so we're not using the between at all. Okay. Over here, this had a open and then a close. This had an open and close, so these both had between statements. But if they just start and then they have an arrow, it's going to be a greater than or less than. Okay. Now here's where you might have to remember how to find this equation of the line by seeing the graph. The purple one, the second one, is a little bit easier. It's the same thing. It's just a horizontal line, so that's y equals 3. And I can see that on the x-axis, they start at 1. So it's going to be greater than 1. I can see the green graph also starts at 1, but goes left, which means less than. Has a dot, so less than or equal to 1. But you have to remember how to do slope and y-intercept and all that other stuff. So remember the equation of a line is slope is y equals mx plus b. And you really need to figure out, well, what is the slope and what is the y-intercept. So looking at this graph, where does this cross the y-axis? At 0. And what is the slope? What's the rise over run? Yeah. Up 1, right 1. Positive 1 over 1. And if you recall, we usually don't write anything with plus 0. We drop the plus 0. And 1 over 1 is the same as 1. But we usually don't write 1x. We just write x. So this is the equation y equals x. So if that came to you pretty quickly and you're like, okay, I remember, you're in good shape. If not, this is going to be a good review for you. You have to have the skill of seeing a graph and knowing what the equation is by finding the slope and the y-intercept. Okay? Notice how on this one I did the domain first. If you don't know how to do, if you know how to do everything else but find the equation on the line, I was still able to find this equation and do both domains. So I can get most of it, you know, if not all of it, because it's so close to everything else. Just have to remember a few things. So try that out on number 5, upper left-hand corner on your notes. Something you can do, if you get your answer, you can go ahead and go to Desmos.com or download the Desmos app. They have it on Android and iPhone. But you can type it in and see if it works. So, for instance, on number 5, what's the first equation? Y equals what? Y equals 2x. Okay. And what's the domain? Okay. So you can see in Desmos, it works the same as it does as the Piecewise. How you put in, we just use, instead of the word if, we have this in parentheses. And then you can type in y equals, what is it? 40? From what?
Greater than equal to.
Okay. Now I have to zoom out to see it. Now, does this look like the one on there? I mean, look how far apart these are. So now you can tell that it's not right. So that's why I encourage you to use it, because some people say, oh yeah, that's it for sure, and then we can use our eyes and see, well, they don't match, so something's wrong. So tweak with it, play with it, see what you can do in order to make it correct. I'll point out what the mistake is, and that is that on here, someone counted up 2 squares over 1 square, but you see it's up 10, right 1. So the slope here is 10, not 2. You got to use the scale when you're counting your slope, not just count squares. So this is up 10, right 1. And if I change this to y equals 10x, now you can see. Now it matches closer. So it's y equals 10x if x is between 0 and 3, and y equals 40 if x is greater than or equal to 3. So Desmos.com, good tool to use. You'll notice on the back here, start on the back, that these don't include the outline of the answer like we had on here. Here I included the f of x with the brace here and the ifs, so you still have to write your answers in that format. So make sure you start off with f of x and include, this is going to be 20 This is 80, so you still have to include y equals 20 if, and then you have to write everything out. So from 0 to 3, including 3, looks like that. And this is just a 3 and above. So greater than 3. So that's how a full answer looks. And you need to write the whole thing. F of x equals the brace, the ifs, the whole thing, just as it is on your notes. At any point, of course, if you do anything less than what you're shown, that's where you're going wrong. So don't exclude something just out of, well, it'll be faster by 0.5 seconds if I didn't write that, and then get it wrong because you didn't write that. Write it all the way out.
Does it have to be in order?
Yeah, try to do from left to right, from top to bottom. Just that way when you guys check tomorrow, everything will be in the same order. It's easier to see. Okay. Let's take a look at the front. There's a couple ways to do this. This is a typical parking sign you'd see at any parking structure or parking lot that, like downtown areas, they have a lot of these that it costs a lot of money just to leave your car there for a little while. Some places more than others. This particular one is an actual sign from Port Canaveral. If you ever been on a cruise in the east, like Caribbean or Mediterranean, a lot of the cruises leave at Port Canaveral. Also, back in the day when we had space shuttles, they used to take off from Cape Canaveral, right there in Florida. But yeah, it costs different rates and for different amounts of time. So we can go in and graph it and say, okay, let's line this up. 0, 1, 3, 4. This is what you would want to be writing at this moment as well. This is the number of hours, which goes up to 12, so I want to count up to 12. And the dollars, right, so this is hours, I'm going to label it hours. The cost on the y-axis, money is always on the y-axis. And it only goes up to $8 here, so I'm going to do every other. 3, 4. Just because I always want to use as much as the graph as possible. If I didn't skip one right here, the whole graph would be like a little tiny section of the whole thing. You don't want to do that. Okay, so consider the values in between. So not necessarily 0 hours, but somewhere between 0 and 1 hour, it's going to be free. So yeah, cost 0. You have to know that free means $0. But at 1 hour, it's going to cost $2. Once you get to 1, it costs 2. Once you get to 2, it's going to cost 4. Once you get to 4, it's going to cost 6. By the way, how much does it cost for 3 hours? 4. 4. When it gets to 6, it's going to cost
6.
8. How much does it cost for 5 hours? 6 as well. And then after that, it costs. How much it costs for 7 hours? 8. 8. 8. Yeah, it says 8 to 12 hours. And it might go up here, but it doesn't say. And then use this as like an x, y graph. So on the graph, on the x, from 0 to 1, should be 0. Because hours is down here, so from 0 to 1, that's this little tiny area right here. That's open circle. And then from 1 to 2, it's going to be at 2. not writing the function for this one, but just taking the sign and coming up with it. Now realize, yeah, when you're walking or you're driving a parking structure, you're probably not going to be thinking of this graph. But you know when you go into parking structure, there's usually a ticket. You have to press a button, you get the ticket, and then on the way out, you put the ticket in and it tells you how much money it costs. So the computer is programmed with a piecewise function to charge you a certain amount of money. This is the exact same thing if you wrote it out and say, well, from this much to this much it costs this much. Somebody had to write the program for that machine so it charged the right amount. And maybe you have a different system for the weekends that cost more or less. So again, one of those things like, well, we never use math in the real world. Let me go into the parking structure. Let me pay. Let me watch an animated movie. It's all there if you just know what to look for. So do tomorrow, finish it up, and we'll continue tomorrow.